So welcome back. Our next part of our CRO is the deflecting system. And in the deflecting system, we have two main parts. We have the Y plates and we have the X plates. If you look at this diagram carefully, you'll note that the Y plates, they have a pair of plates. Then we have one on the lower side and one on the upper side. They are placed in a vertical axis. Then the X plates still a pair, but they are placed in a horizontal axis. So these are the X plates. Then we have the Y plates. So the function of the Y plates, which are the first plates we have here, just after the anode, we have the Y plates. They are vertical. We have one on the upper side and one on the lower side. Let's call this plate A and we call this plate B. In this, I have connected the X plates across a DC, a direct current. With this being the positive, then it means plate A is connected to the positive terminal and plate B is connected to the negative terminal. When you are looking at the properties of cathode rays, we realize that cathode rays are deflected by an electric field. So when this switch is open, then it means there is no complete circuit, and therefore there is no field in between A and B. And therefore, if we head the cathodes, they'll move straight and hit or strike our screen at this point here, the central point. Let's call it point A. Or because we've used the letter A, let's call it point M. When we close this switch, then it means that this is now positive and this is negative. And for that reason, the cathode rays being negative, we realize they are attracted towards the positive, and therefore the path will be altered, and they will be slightly attracted towards the upper plate, and they will fall at an upper point from point M. Let's call that point N. If we were to interchange this such that now B is connected to positive and A is connected to negative, then this will be the plate which is positive and this will be the plate which is negative. And therefore, this cathode beam will be attracted towards B and it will fall on a lower part. Let's call this point P. Therefore, when we don't have, or when this circuit is open, the beam will not be deflected. It will move up to point M at the central point. When A is positive, then it will be attracted upwards. When B is positive, it will be attracted downwards. But this is a DC. Therefore, in that case, if we just connect this, then that spot will continually fall at that point. But you realize that in the CRO, the input of our Y plate is not a DC. It is an alternating current, an AC. Therefore, we connect our Y plates now to an alternating current. Remember, in an alternating current, the terminals keep on interchanging. At one point, this is positive, this is negative. Then the terminals alternate, and this becomes positive, and this becomes negative. A good example is our mains electricity. It alternates at 50 Hertz. 50 Hertz, approximately 50 Hertz, means that in 1 second, these terminals will interchange 50 times. Therefore, that means that if we have an alternating current, when this is positive, we will see this dot moving upwards on the screen up to the maximum voltage. Then when this voltage interchanges, remember, an alternating current will always build to maximum, then die to minimum, increase in the opposite direction to maximum, then die to minimum, increase in the opposite direction to maximum, and it keeps on alternating like that. Therefore, as this voltage increases to maximum on this side, then we'll have this dot moving from the central point to the maximum point at N. Then, as it decreases to minimum, this dot will be seen moving back slowly up to point N. Then, this now will be positive, and therefore, as it builds to maximum, the dot also will be moving on the lower side up to the maximum voltage at point P. And this dot now, when we look at the screen of the CRO, which is graduated in squares of 1 centimeter, then we'll see the dot moving from this point. It rises to the maximum point, then it comes back to the point, the central point here, then it moves to the lower side. So we'll see the dot moving up and down, vertically on the screen. And that's why we are saying that the Y plates cause a vertical deflection on the beam. As this dot moves up and down, it will be seen moving up and down depending on the frequency of the alternating current. If this frequency is very low, then this dot will be clearly seen moving on the screen in a vertical position or in a vertical axis. But if this frequency was to be very high, that is the rate at which A and B are alternating, the frequency is very high, then the dot will be moving across the screen very fast. And therefore, what we shall see on the screen is not the dot moving, but we shall see a vertical line. A vertical line will be seen on the screen. And the reason why we see this vertical line is because of two things. One, the speed is too high. And because the speed is too high, we have what we call persistence of vision. Persistence of vision. When you look at an object, when the image is made on the retina, even after the object is removed, that image remains in the retina for a few more seconds. Therefore, if this dot has already moved, but the image here still remains at that point in the eye, so it is perceived as if the part is still glowing. The other thing why we are going to see this as a straight line is because of the persistence of glow. Persistence of glow. When this beam hits a point, even after the beam leaves, that point is left glowing for a longer time. And it has phosphor has a persistence of around 0.05 seconds. Therefore, the point has already passed, but that point is still glowing. Therefore, when the frequency is very high, we are going to see a vertical line. Even though the dot is moving, it's only that it's moving and doing so at a very high speed. Next part, let's look at the X plates.